I had a question from a customer about print modes, resolution, and color printing with a latex printer. And the question, for me anyway, I think expressed a misunderstanding about how latex printers work if you're more familiar with how a piezo printer works. So the way a latex printer works, and here I have a latex thermal print head. These are thermal print heads. They have a 1200 dpi resolution and a 12 picoliter drop in all print modes. So if you're printing 6-pass or 8-pass or 20-pass, 1200 dpi, 12 picoliter drop. The resolution does not change. So when people say, well, I want to print a slower mode to get more quality or more resolution, you're not going to get more quality from 8-pass to 12-pass, for example. It's going to stay the same. 8-pass, printing 100% density with the same ICC profile, will look the same as 12-pass at 100% density. The reason why is because you're using a 1200 dpi print head in all modes, and you're using the same drop size. Now with a piezo head, your resolution usually changes as well as your drop size as you go faster. So printing in different modes or different speeds with a piezo is a different experience than with a thermal latex. What the thermal latex does change is the density of the ink. So for example, I said earlier, if you print 8-pass 100% density with the same ICC profile, and you print 10-pass 100% density with the same ICC profile, they should look the same. You may have a difference in which one is dry, because the last factor is, the faster it's going through the printer, the more time it needs to evaporate all of the ink, water-based ink. But the faster you go, the less ink you can usually put down, because you have less time to evaporate that ink and make sure everything is completely cured coming out of the printer. So the rule of thumb is 6-pass would be 80% or 90% density. 8-pass would be 90% or 100% density. 10-pass would be 110% density. That curve holds true for most medias. The variable is medias have different thermal deformation points. So some trim banners, like say a Bantex 13-ounce curl-free, is very temperature resistant. You can put the maximum amount of temperature, 241 degrees, no matter what you're running, and it's not going to make any difference on the material. It's very temperature resistant. But if you took a 10-ounce PET Super Smooth, it's very temperature affected. So any change in temperature over, say, 190 degrees is going to turn it into elasticity. It's going to turn it into bubble gum. It's going to warp and cockle all over the place. Those differences are a result of the thermal deformation point of the media. But if a media will take the same temperature, a high temperature, then what's changing is simply the amount of ink you're putting down, and the amount of ink you put down affects the overall color gamut. So a print at 80% density is going to be a little lighter and use less ink. It will cost less. But the resolution would be the same as a slower print. The drop size is the same as a slower print. What's changing is the amount of ink, the richness, saturation. So that's how the latex thermal print head works. That's different from piezo head. And if you understand that, now, if you're going very fast, say 4-pass or 6-pass, there's other variables which happen which can affect the sharpness or accuracy just because of the speed of the carriage and how quickly it's going through. It might look a little sharper, have more clarity at 10-pass because of the speed. But as a general rule, there is not a very significant difference because I'm not using different drop sizes and I'm not using different resolutions. Those stay the same. There may be other variables associated with that can contribute or subtract from quality, but it's not resolution and it's not drop size. Just something I want to explain how the latex works that's different than other technologies. So when you print, 8 pass 100, 10 pass 100, and 12 pass 100, and all three look the same, that's correct. That's how they should print. But knowing that you can print 12 pass should allow you to put more ink down. You could say put 110 or 120% density, and that's going to be a richer, deeper, more saturated print with a wider color gamut than printing at 80 or 90% density on the same material at 8 pass. What's changing is the amount of ink, and that's going to affect how you perceive print, and that's going to affect your image quality.